Hello, everyone. In the previous lesson, we completed the design of the DC-regulated power supply circuit. In this lesson, we will make preparations for the DC-regulated power supply soldering according to the schematic diagram of the circuit. The preparations include obtaining information, making a plan, and implementing decisions. Through this lesson, we will understand the basic process of making a DC-regulated power supply circuit and master the essentials of circuit soldering. The key and difficult points of this lesson are the testing and soldering of components such as resistors and diodes. An ancient saying goes, "He who fails to plan is planning to fail." It means that the implementation process can be well organized, targeted, and efficient only if the data and information about the relevant knowledge are fully acquired beforehand. Therefore, our first step is to acquire data and information. Understand the component list for this task. Learn the methods for testing the components in the list. Acquire knowledge about manual soldering, and become proficient in applying these skills. Before soldering, let's think about the following questions. 1. What components are used in the DC-regulated power supply circuit? 2. What are the steps to measure resistance using a multimeter? 3. How to determine the polarity of pins of a diode and a LED? How to determine if they are functioning properly? 4. How to calculate the capacitance of a capacitor? How to determine the polarity and condition of pins of an electrolytic capacitor? 5. How to test a 6-pin self-locking switch? 6. What are the functions of each pin of the 3-terminal voltage regulator LM1085-5? 7. What tools might be needed for manual soldering? 8. What are the hazards of static electricity and how to protect from it? 9. What are the basic principles for installing and soldering components? 10. What are the requirements for bending and shaping the pins of components like resistors when mounted horizontally? What components are used in the DC-regulated power supply circuit? According to the schematic diagram of the DC-regulated power supply circuit, this circuit includes resistors, diodes, capacitors, a self-locking switch, and a 3-terminal voltage regulator. The component list is as shown in the diagram. What are the steps to measure resistance using a multimeter? Choosing the correct parameters for the components is one of the conditions for achieving the circuit function. Resistors used in the DC-regulated power supply circuit can be tested using a multimeter. The steps are as follows. 1. Adjust the meter pointer to the 0 mark. 2. Select the appropriate range. 3. Adjust the ohm to 0. 4. Measure the resistance. 5. Read the figure and calculate the resistance value. How to determine the polarity of pins of a diode and a LED? How to determine if they are functioning properly? Diodes and LEDs are used in this circuit. 1. Simple determination of the polarity of a diode's pins. The pin with a black or silver mark is the negative electrode. For LEDs, the pin with a longer lead is the positive electrode. 2. How to use a multimeter to determine the polarity and condition of a diode's pins. Set the resistance range of the multimeter at either a ×100 or a ×1000. Then test the diode. If the pointer moves forward or doesn't move at all, it indicates that the diode is functioning normally, and when the pointer moves forward, the pin in contact with the black probe is the positive electrode of the diode. If neither of these states occurs, the diode is already damaged, either shorted or internally open. 3. Test LEDs. Set the ohm range at times 10,000 for measurement. The method is similar to that for regular diodes, but the difference is that when the pointer moves, indicating the LED is conducting, the LED will emit light. How to identify the capacitance of a capacitor? The capacitance of a non-polar capacitor is usually labeled digitally. For example, if it is labeled for 174, the capacitance is 47 times 104 picofarads equals 0.47 microfarad. Electrolytic capacitors are labeled with capacitance and maximum withstand voltage using the direct labeling method. Electrolytic capacitors are polarized, with the negative electrode marked on the casing. If the leads are not cut, the longer one indicates the positive electrode. How to test the performance of an electrolytic capacitor? Set the multimeter range at a times 10, a times 100, or a times 1000 for testing according to the electrolytic capacitor's capacitance. First, discharge the capacitor. Then, connect the red probe to the negative electrode and the black probe to the positive electrode of the capacitor. If the capacitor is functioning properly, the meter pointer will initially deflect to the right and then move back. The greater the initial deflection and the slower the pointer returns, the higher the capacitance. If these characteristics are not observed, the capacitor is either faulty or damaged. This circuit comprises a 6-pin self-locking switch with a mechanical locking feature. It includes 2 sets of switches, each with a pair of normally open, NO, contacts and a pair of normally closed, NC, contacts, with the middle pins as the common terminals. When the button is pressed and released, it stays in a locked position without fully popping up. At this point, the NO contacts close, and the NC contacts open. Press the button again to unlock it, allowing it to fully pop up, and the NO and NC contacts return to their original states. How to test the NC and NO contacts of the 6-pin self-locking switch? Set the multimeter to the resistance range a times 1. Place the red probe on a common terminal and the black probe on an adjacent pin. If the multimeter pointer deflects towards 0 ohms, press the button. If the pointer moves towards infinity, it indicates that these pins are NC contacts. If the pointer deflects towards infinity, press the button. If the pointer moves towards 0 ohms, it indicates that these pins are NO contacts. If the multimeter pointer does not deflect after the button is pressed, it indicates that the 6-pin self-locking switch is damaged. What are the functions of each pin of the 3-terminal voltage regulator LM1085-5? In this circuit, we use the 3-terminal voltage regulator LM1085-5. The pin functions are as shown in the diagram. Pin 1 is the adjustment pin. Pin 2 is the output pin, and pin 3 is the input pin. What tools might be needed for manual soldering? The tools used for soldering include electric soldering iron, diagonal cutting plier, tweezer, soldering tin, rosin, screwdriver, wire stripper, and solder sucker. What are the basic principles for installing and soldering components? After counting and testing components, we begin to prepare for soldering. What are the basic principles for installing and soldering components? 1. Components must be installed correctly according to the indicated polarity. 2. Installation should follow the principles of proceeding from light to heavy, from inside to outside, and from low to high. Why is it necessary to protect against static electricity? How to do it? Semiconductor electronic components are sensitive to static electricity. Static electricity can generate very high voltages, an electrostatic discharge can damage semiconductor components or significantly degrade their performance. Therefore, when installing and soldering circuits or handling semiconductor electronic components, it is crucial to implement proper electrostatic discharge protection measures. Wear antistatic clothing and hats. Use antistatic shoes. And wear antistatic wristbands. What are the requirements for bending and shaping the pins of components like resistors when mounted horizontally? In this circuit, components such as resistors and diodes are mounted horizontally. What are the requirements for bending and shaping their pins? The pins should be bent at a distance greater than 1.5 mm from the base of the component. The bending radius should be greater than twice the diameter of the pin. After bending, the two pins should be perpendicular to the component. Having completed the study of the data and information about the DC-regulated power supply circuit, we now move on to the second process, developing a work plan. Through the study of the above content, we have gained a general understanding of considerations in component testing and soldering. Next, we will draft a work plan based on the basic principles of component installation and soldering. The contents include the preparation list, work safety, work quality, environmental protection, and working time. A work plan helps us further organize our work and improve efficiency. Next, let's move on to the third process, implementing decisions. After discussions with classmates and teachers, we determine the work plan and begin the installation and soldering of components. In this lesson, we've mainly learned what components are used in the DC-regulated power supply circuit. 1. What are the steps to measure resistance using a multimeter? 2. How to determine the polarity of pins of a diode and a LED. How to determine if they are functioning properly. 3. How to calculate the capacitance of a capacitor. How to determine the polarity and condition of pins of an electrolytic capacitor. 4. How to test a 6-pin self-locking switch. 5. What are the functions of each pin of the 3-terminal voltage regulator LM1085-5? 6. What tools might be needed for manual soldering? 7. What are the hazards of static electricity and how to protect from it? 8. What are the basic principles for installing and soldering components? 9. What are the requirements for bending and shaping the pins of components like resistors when mounted horizontally? That's the end of this lesson. Thank you for watching.